Future Now Show. Brought to you by the Club of Amsterdam.
Welcome to the Future Now Show, where we explore the cutting edge of technology, innovation, and wonders of the digital age, featuring interviews with global thought leaders, entrepreneurs, and visionaries whose ideas and projects are shaping tomorrow's realities. Today, we're discussing the quantum relations intelligence with returning guest Hardy Schloer, founder and CEO of the Alpha Centauri Group. And we're going to be talking about this groundbreaking technology and how it's redefining our understanding of artificial intelligence. Hi, Hardy. Welcome back to the show.
Nice to be on your show. Thank you very much.
All right. So what is the core concept of quantum relations intelligence, and how does it differ from our current approach to traditional AI models?
Well, it's a big question. Has many answers. And so let's start first about to zero in on actually what intelligence is before we even get to artificial intelligence. Let's get to something that actually we humans can understand, something that is native to us. Because if we create anything that is artificial intelligence, it should be something that can be understood by us, or it has to be at least native to the way our cognitive intelligence model works. So when we look at current AI, as you just mentioned, the very, very disappointing thing about current AI is that it is nothing other than what we did in the 1960s. It's neural nets. The emperor has new clothes, but it's still the same thing. Now we call it machine learning and generative AI and all kinds of other fancy names. And we go on the premises that neural nets supposedly are representing how our brain works. And I completely differ from that. In fact, absolutely sure the brain does not work like this. So how does the brain actually do work? Well, the brain has two things. It has neurons and has receptors. And what it is storing is sensations. I don't know how current AI is detecting sensations. Right. It doesn't. So what is interesting about sensations is that when you have a sensation, then there is something changing from one state to another. And the inference of that is the sensation which you record or which you understand through your senses. You see, you hear, you smell, you feel, and so on. When the brain takes that information in, it does so by associating it. It quantifies it, it qualifies it, and it associates it. And that's all the brain does. So, for example, when you were, 2 years old and you were hungry and you were walking through the house, mom wasn't there, and something in your stomach told you you're hungry, then that was a sensation you were feeling. And then you were smelling somewhere in that direction over there. There was something that you wanted to have, to eat, to take in. So that's an orientation. That's another sensation. And you would go towards that orientation and you would go into something that you later understand is called the kitchen. And as you go into the kitchen, you see this white thing that you later understand is called a stove. And you associate the stove with something that is related to your hunger, something related to food. And sure enough, you see this round thing on top, and that later you understand is called a pot. And that pot, some steam is coming off. And you know when that round thing has some steam coming off, very soon mom sets you on a table, puts that pot on the table, pulls something out, puts it on your plate, and you eat it. That's what you want. So you go right there because mom isn't there, and you reach for that pot, and ow, you burn yourself because you just touched the hot plate on which the pot is on. You now associate pain, heat, also with making food. And so this is how you learn at a ferocious speed when you are 1, 2, 3, 4, 5 years old. All these associations, all these things. And there's another thing that the brain does. The brain stores events. And it does so by us taking all of these associated sensations and encapsulate them in something we call events. Now, when you think back when you were 5 years old, you don't remember, well, it was January the 1st and the 2nd and the 3rd and the 4th, and you have this linear understanding. No, what you remember is you fell off the bike, you know, and busted your knee. There was an event that stuck in your mind. And then that one day when you dropped grandmother's favorite vase and it broke and grandmother was all upset. This is another event, you know, and so you store your history in this long accumulation of events. And in each event, you have these associative elements, and they are having features of quantity, quality, and association. And this is how the brain learns and understands. Now, taking that is a far, far cry from what a neural net is or what generative AI is. It is something that is taking huge amounts of language, numbers, symbolic information, and runs it through a neural net machine learning process. And on the other side comes something out that is aligned with a completely artificially generated associative thing that sounds right, maybe grammatically, but nobody knows how it brought that together because it cannot tell you afterwards what the sources were. What is if the source was the New Scientist or the Scientific American, or it was the National Enquirer of the exit aisle of the grocery store somewhere in Kentucky?
Right.
Because the neural net treats them equally. It doesn't make a difference between these things, but if it can squeeze them into sound as an intelligent output, it will do so. And we don't know where it came from. Anyway, the application of machine learning is very limited. Now, don't take me wrong, machine learning is a very cool thing, but only when you use it in the very, very, very final step of doing something. For example, face recognition, for example, biometric recognition, and so on. But there is another big problem with current AI, and this is before we go into actually how do we solve all these problems. One of them is that for every problem, for every vertical, you have to build a new solution. You have to do a new machine learning element. None helps the other. So you have to keep on building again and again and again and again and again a new solution for every single problem that you're trying to solve. Now, a chatbot and for example, that's what most of the so-called, amazing AI is these days. It's mostly chatbot.
Right.
That is only one vertical, no? And it's to boot one that's a black box. You can't qualify it. And there's many examples. And actually very funny ones. I recall the one from that law case in New York where a lawyer actually used OpenAI to generate 5 legal cases to support a client's personal injury case from an airplane. And the judge asked where these cases came from. He said, well, they came from OpenAI. And of course, OpenAI entirely invented these 5 cases. They didn't exist. But the lawyer didn't know that. I think the lawyer got probably sanctioned or whatever. But it's actually a funny case, And there's many other ones. And of course, these guys that created OpenAI, they're working very hard on doing that. But anyway, I'm not knocking what they do, because what they do is clever, it's interesting. It's just not intelligence. It's just not intelligence. It's very useful, and I'm sure there is a very good application for it. And it's a very nice consumer app. Brilliant. I love it. I have used it occasionally myself, mostly to entertain myself, not really to do serious research. But there's a lot of things it can do. It can write code. It can do all kinds of things. But this isn't what is going to change the world. This isn't what the world actually needs to build what I think we need, and that is a comprehensive global model. First of all, we need to build an AI that is completely agnostic to any domain, to any vertical.
Yes, totally agree.
Okay, so that's number one. We need to do that. Well, we've done that. We need to have a data model that is global, that allows anyone to use it like a standard, so that information now becomes machine-to-machine usable without any human intervention. Because if you really ever want to get to the point where we can run this very, very complex planet through AI, and we need to get there very soon, and I get to that a little bit later, why? But if you do, we need to have a common global data model. And on top of this common global data model, we need to have a domain agnostic analytics engine that actually can understand this information. Now, interestingly enough, let's go back to knowledge one more time. There are really only 4 types of knowledge, only 4. These 4. And what they are raw, what I call raw knowledge, symbolic knowledge, which is numbers, texts, one thing at a time, a video clip, a book, a report, a paragraph, a news report, whatever, a press release, a blog, whatever. So that's raw stuff. And for ever since Gutenberg, at least, or maybe even much before that, we are used to only that kind of knowledge. And throughout all of our school and all our universities and so on and so forth, we consumed knowledge in that way. Read one thing at a time try to remember it, take the next thing, read it. Go from one school book to the next, go from one page to the next, go from one chapter to the next, and then trying in the end to sort of make sense of what it all means. Well, perhaps at the time of Socrates, that was still something that was somewhat feasible with somewhat limited amount of information. But we are now living in an age in which we are every single day produce more information than we have since the beginning of time until the year 2019. Think about this. When I say this one more time, let this sink in. Today, we produce every single day more information than we have since the beginning of all recordings of all information until the year 2019. That is how the explosion of information has gone into the stratosphere. Now, in that day and age, with almost 8 billion people on this planet and huge amounts of problems to solve, whether they are geopolitical or they are environmental or they are social or they are in other ways, we have to have the ability at any given moment to understand the totality of all there is to know, of all that can be considered at one moment in time. And when we do that, we need to move from raw knowledge to the other three types of knowledge. And these are the only three other types of knowledge that exist. And everything is nothing but a derivative of it. And that is quantitative information, qualitative information, and associative information. Nothing else. So you see, when you begin to generalize what actually knowledge is, you just need to get down to the real general basics and then work from there. Build a model from there. There's another very interesting thing that I mentioned earlier, and I want to mention it now again in conjunction with that. What we process, what we memorize, what we find memorable is not what things are, but what they cause. When we meet a person, then we generally want to understand what the person says, how the person makes us feel, what the person does that has any relevance, impacts, or notoriety to us. If a person is just a statue that doesn't move, do nothing, it doesn't have any effect on us. But as soon as that person speaks, moves, behaves, now we are retaining that.
Yes,
that's actually what makes us understand. And this, what is true for a person, is true for all 8 faculties of the thinking of the brain. And I'm going through them right now because they are really interesting to understand. And I'm mentioning them in my new book. Humans do only 9 things. One is they retain what things cause, and we call that causality, cause and effect. So everything that we understand is causation. Even something like a sofa, you look at a sofa, what does it cause? It causes you to sit comfortably down, rest, take a snooze in the afternoon and have a siesta, or sit there with your family. It has a causation through which you recognize what it does for you. what it represents to you in the way
Making the connection.
Bingo, exactly. And that's why the brain is a association machine. Now there is simply 8 cardinal elements, and I'll show you them here. 8 cardinal elements that the brain uses to process any information, any. There is no others than just these 8. When I give sometimes lectures, I tell my students, please, try to come up with anything that exists anywhere in this universe that cannot be represented through these 8 things or a combination of them. None of them has ever come up with anything, even how hard they ever tried. So just to go very quickly through them, one of the most important things to us humans is other humans. There's a very large landscape in the Pinakothek in Munich, and there's trees and lakes and all kinds of amazing things. And there is this one tiny little boat on this little lake amongst all these other things that are on this painting, and it's a huge painting. And there's, in this boat, there is this tiny little fisherman that is fishing on that little lake. And you can show this to 100 people, this painting, then take them to the next room and say, can you describe what you just saw in this painting? And although this little tiny boat with the fisherman is a speckle in the whole thing of the painting, almost everyone mentions that fisherman. So this is because our species, this is ingrained in us from hundreds of thousands of years of evolution, we are constantly looking for other like us, humans. So this is the #1 cardinal element that we are processing. And then the next thing is that we are looking for patterns. You know, we see a pattern of trees and we call them forests. Or we see a pattern of birds and we call them a flock of birds. It's interesting that for any pattern we have special names and we immediately know what they are. And so there are other patterns and we call them groups. For example, organizations, companies, or a platoon of soldiers, or so on and so forth. So these are things that group. They have what we call a conceptual belongingness. That's another element that we process. Then the next thing is geography. Where is something? You know, it can be the dark side of the moon, the inside of your right pocket of your pants or whatever, but geography is a very important element. No? And then there is the next thing we call events. We talked about events earlier. We retain and model everything through events. If you think about anything that you remember, it always relates somehow to geography, events, and the next thing, time. No? That's very important because through time, then, we can order these events. Did you fall off the bike before you broke the vase of your grandmother, or was it after? Was it in the spring or was it in the summer? So what we do is actually, we're doing in our brain another very interesting mathematical thing. We create time series. Time series. So we have these sensations, these associations, and we put them in timelines. And they have qualitative and quantitative elements and features, and we associate them through this timeline. Do you see how we sculpturing suddenly this vehicle out of all these things that we think and feel and hear and so on? Then, well, we were talking about now humans and groups, geography, events, time. The next one would be technology. And technology is not something that is new. No, technology was when a monkey took a straw 200,000 years ago and stuck it in a fruit to suck out the juice. that was technology. Or when a Stone Age man took a stone and shaped it to make it more pointy so he can smash the skull of an animal so he could kill it and eat it, that was technology. And of course, now technology is something much more sophisticated. But technology also is the clear evidence of intelligence, of the ability to model, the ability to create, the ability to evolve. So that has to be one of the 8 elements that the brain uses. And what I call generally the things with purpose, results of intelligence, or what I call technology, that is actually the element that helps us to evolve. And then there's only 2 more. One of them is concepts. And concept is something we begin to understand at about the age of 3. So before that, we would say, Mom, I just saw a pink elephant flying by the window and he had red dots on his white back. And Mom would say, what are you talking about? Nonsense. Of course that is not true. Yes, it is true. Why? Because the child can fantasize and thinks whatever is in my fantasy must be true, must be. But then at about the age of 2.5, 3, the child begins to understand that there is something they called a lie, untrue. So that's the first thing of learning what concepts are. And then they define, abstract ideas, feelings, definitions, ethics, morals, all these things are expressed through concepts or conceptual ideas. And that is another element also of intelligence. And then the last thing is something super simple. We call it objects. Anything that takes space up in our universe, whether it's a gas cloud or it's this bottle here or a table or a stone or a car or a spaceship or whatever, doesn't matter. All of these are objects. Animals, whatever. Anything that takes up space other than humans. We give them a special element. So, and that's it. These are the only elements our brain processes. So now if you take all that I said now together, you can build out of that a beautiful data model. You can now take all of that, parse that out of any language, any picture, any video, any sound, any number that you retain, because the number is associated to something. For example, a number comes out of a thermometer, then that has, a certain meaning. It's a quantitative understanding of a temperature, for example. So we can easily now take all that we can observe in this universe and just sink that into this beautiful generalized data model. Now, once you begin to associate all of that, then it becomes representational of the universe. Now, we, you, me, any other human, we have a very, very limited capacity to take in what is out there in this universe. Machines do not have that limitation. As long as that we can literally take anything that digitally moves on this planet and import it through that generalized data model, we can build a complete and total representation of the entire universe inside our machines. Not one, but thousands of machines. Now here comes a really important element. Let's go back to machine learning. So there is, and this is not original with me, there is probably more than 200 studies Some of them are from Carnegie Mellon, from MIT, from Stanford, from very reputable universities around the world that are looking at the energy consumption required by machine learning to use machine learning everywhere in our daily life, to try to solve everything through this black box approach of machine learning or generative AI.
Massive amounts of power, massive amounts of data,
I
and
want
very
to
large
give
data
you, I
centers.
want to give you a shocking revelation, and that is that between 2026 and 2030, likely AI alone, due to the enormous adaptation of AI everywhere, which can no longer be stopped, everything is going to AI. In that time period, somewhere between 2026 and 2030, AI machine learning will consume more electricity than the rest of the entire planet combined. Now, in a world in which we have enormous environmental problems already through pollution of energy production and so on, this is not good news. It's totally unsustainable. So we are running already now into enormous problems, data centers using incredible amounts of energy, and it's going up exponentially. Why is that? Because what we have done is, to make it really simple and for any novice to understand that is not familiar with artificial intelligence, what we've done is we took dumb data and using very energy consuming kind of complex programs trying to find out what the answers are to our questions. At quantum relations, we do exactly the opposite. We don't make the machines or the analytics process so smart, although it does some clever things, but we shift everything to make the data smart. By importing the data through this cognitive model that we have plagiarized from nature. Because what we've really done is we haven't invented anything. All we have done is we plagiarized God. We plagiarized what he did in the human brain. That's a great model. And it's native to us, so why not use it? And what it does is it makes data smart because it stores it as sensations, as causations, as associations, and so on. So right from the beginning, it's all there. And it's a quite simple process. We're using parsers that understand how to add all these associations and features and causations to extract them out of data, tag them with it, and store them in our quantum relations database. Once you do that, then asking questions becomes an incredibly simple process. Because I can say, give me this answer, and all relevant data that is belong to that answer says, here I am, boom, comes and associates, and it gives us answers, number one, that have a very, very significant low false positive rate. That's very important. And it lets us find the needle in the haystack instantaneously. And even better than that, I know exactly where the answer came from. I know exactly how the associative process works, because I can even visualize it and look at it. And
That's a
then I
big
can
one.
go and I can filter. I can say, look, I want an answer that gives me a qualitative information or quantitative information or associative information about this question, but I only want it to come out of sources that have a very, very high fact check score, or a medium score, or a very low score. Maybe I'm after, things like QAnon and the latest conspiracy theories and
Going down the
whatever.
rabbit hole.
Yeah, no problem. Then I can go for that. This is not a problem.
Right.
I can, or I can even go further than that, because I can filter in a qualitative way anything. I could say, give me an answer that represents the American-centric thinking of the Midwest, or of Israel, or of South Africa, or give me something that is centric in its approach to Asian thinking, or something that comes out of information that is academic, or information that you make it up, whatever qualitative limitation you want. And it won't take you years of studies to find the information. In our system, it takes you milliseconds to do that. Milliseconds.
Now, do you have to worry about IP and where you're getting the data for this QRI to train on? Or is that not really an issue?
Great that you mentioned that. Wonderful that you mentioned that. Now, there is this lawsuit now going on between, I think, OpenAI and the New York Times, or is it?
Yes.
I think it's the New York Times. Yes.
It is.
So in our case, this is very simple, because we know who the contributors are to our information. So we can analyze it, but if you want to see it, then whatever is free, you can see, and to whatever you need a prescription, a subscription, then it will tell you, please go for this information directly to the New York Times and read it there, or from the Economist, or from wherever it is. So what we do, it's perfect, because we have a white box, and we know every single source that contributed to the answer. We can, for every element that the user wants to see, we just send them to the original source, and he can then work out his subscriptions or whatever he needs to do. That is another great example that is not possible with black boxes. But we are a white box, so no problem with that. And in fact, publishers should love us. They should love this kind of AI, because it will actually allow them to charge for their stuff, or not to charge, however they wish, however they want. This is not a problem. Typically, you're allowed to cite a headline, and sometimes the first paragraph, or the first sentence. So that is, if that is allowed, then we will show that to the user, and then the user can just go right to it. The beauty about this system is that it gives us the ability to bring down the energy consumption by more than 95%.
I wanted to ask about that, because you mentioned it being a network of computers that could be openly shared. Is it something along the lines of what SETI did? Are you going to allow open collaboration with people
Yeah, yeah, yeah.
to help
Of
produce the
course.
energy?
Yes. I'm trying to think how we overlap and so on. Yes, of course. Here, what quantum relations does, actually, what the product is we are putting together is that, number one, we want to introduce something to the world that is making sense as a standard, as a data standard. As you know, there were for years and years and years, people tried to figure out how to build a semantic web. And the semantic web implementation is only a byproduct from what we've done. It's happening by itself automatically. So if you use the model that we are building or have built to store data, to actually take in data and use it, it will be perfect. It doesn't matter whether you use it for intelligence or you're using it for commerce or you're using it for education or you're using it to create better medical research or do better drug research, or it doesn't matter. Now, one of the beautiful things about our system is, and I said this in the beginning, it is domain agnostic. So which means if you want to analyze something, you can analyze it with as much context as you choose. You can either say, okay, I want to stay very narrow in my context. Let's take an example out of medicine. So you want to analyze the general health of a person. Now you can consider for that only his last blood test or all the blood tests he had in the last 30 years. And you can add to that, what is his environment? Where does he live? What is the level of stress that he's under? What is the domestic situation? What is his genetic context? What kind of work does he do? What is the social environment in which he lives? What is the typical food that he consumes? What is the level of pollution under which he lives? You see, when you just look at the health of one person, and you can go outwards and outwards and outwards and just look all of these contextual things, and they all have an effect on what the general health of one person is. And now you can extract out of that a lot of probabilities. Now, for those that haven't had a lot of background in computer science, I want to explain this, but what actually I just explained is a model under which we take unstructured data and turn it into a completely numeric environment. Because everything now, by being parsed into this data model, it can be expressed by numbers. Also qualitatively, quantitatively, and so on and so forth. When data becomes pure numbers, then we can do something what we call the quantum cube. And what the quantum cube allows us is that we bring everything in that is domains with respect to quality, to quantity, and with respect to occurrence, and so on and so forth. And once we have done that, then we can overlay that with events. And we can find what we call stochastic signals in time series. What that means in the end is that by having this very large global model of information, is that everything becomes highly predictive. Highly predictive. In fact, we will understand when an event about to happen, when the peak of the event is, when the event subsides, when the event is over. Before it happens. Because we will find in this massive amount of numeric data And now here the machine learning is useful. But here it's simple, because here we are not doing the heavy lifting. The heavy lifting is done by the way we are bringing data into the system, in the same way as you bring data into your brain. Exactly the same way. And by the way, your brain is completely agnostic to any information. You don't say, well, this is my brain that thinks only about medicine, and this is my brain that thinks only about what I'm doing at home and what dinner I cook, and this is the brain that only does what I do in my job. No, it all blends together. And the same happens here. And when it all is blended, then you have a beautiful global model in which you can find all these signals that are foretelling of things that need corrective action on our part, or there are opportunities that we can leverage. So this is just a very rough introduction to what quantum relations aims is and what it should solve. Now, once you use our data model, and once you use our tools, the quantitative, qualitative, and associative tools that we have built that intersect with that, the information that you can get out of that by just querying is simply shocking, because you have, it is as simple as just remembering something that is vivid in your memory. And it's just let the machine remember something that's vivid in its networked memory across thousands of machines and databases, but it will find them instantaneously, because every piece of information is connected to every piece of information. It is a complete information ecology across all domains, across all there is. And that's basically what quantum relations is and what quantum relations technology is. And it's, again, not something that is so terribly smart on our part, but we've just been very observant how nature created thinking inside us. And all we have done is we coded that into a machine environment. And now the machine basically does exactly what the human brain does, but does it in a scale that could never be done by a human. Just imagine you have all 8 billion humans on this planet could fuse their brains together to think as one brain. And every memory in every brain becomes accessible to every other brain in that ecology. That would be amazing, wouldn't it? Sounds like a science fiction, right? Well, we can make that science fiction by just taking anything that is digitally output anywhere in the world and incorporate that into the quantum relations model.
All right, one last quick question before we go. Where can we find QRI now? Is it available yet? And if not, when can we see it?
QRI will be available by March or April of this year. Initially, only for a couple of very, very selected customers. But by probably May, it will be available in a very, very broad way.
Okay, great. Well, we're going to have you back on the show because we need to talk about your new book. All right. That's a must. All right, Hardy. Well, thank you so much for joining today. I really appreciate it.
You're very welcome. It was a pleasure being on your show.
All right, that's it for today's Future Now show. We'd like to extend our thanks to Hardy Schloer for joining us again and sharing his insights on the QRI, Quantum Relations Intelligence. It's clear that the future of AI is not just a distant dream, but it's a rapidly unfolding reality. So technologies like QRI are at the forefront of this transformation. To our listeners, thank you for tuning in and being a part of our journey into the future of technology and innovation. Remember, the future isn't just a destination, it's the direction we choose to take. So join us next time on the Future Now show. Until then, keep thinking forward, stay curious.